So here comes that example 5 again, but this time we're going to do it the slick way. What I mean by that is we're going to take advantage of the fact that we do not have to have dx at the end of every single integral. We can use dy. All right, so here's how that's going to work. First of all, go ahead and copy those details down right here. We've got the same equations, x equals y squared and y equals x minus 2. We're going to get our picture going again, so let's just draw another version of that. We don't have to spend too much energy on the graph, but you know, we can make it look fairly decent. So we'll go up 1 and 2, and we'll go down -1, maybe -2 like so. And let's see, if I went out 1, 2, 3, 4, it would be up here at 2, and then down here at -2. So the graph, let me switch colors here. So this is the graph of x equals y squared. Not the greatest picture, but I think we get the idea. Oh, I shouldn't have put arrows on those because I think at this point right here, and this point right here, I can put the arrows beyond that. That's fine. Okay, sorry about those points. Those are kind of funky looking, but we're going over to 4, 2, and 4, -2. That looks good. So that's x equals y squared. And again, if you just want to pick some x and y values, you can kind of confirm that that actually makes sense. This should be at 1, 1 right here, and 1, -1. I'm a little bit off, but I think we'll be okay. All right, next up, we got y equals x minus 2, which goes through the point 0, -2, and it rises 1, runs 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. It's supposed to hit perfectly at that other location 4, 2. You can confirm that by just plugging in a 4 and getting 4 minus 2, which is 2. Okay, so I apologize for this really awful picture, but it's going to do the job. It is definitely going to do the job. What I'd like to have you recognize now, and I can't rotate my screen, but if you could turn your paper sideways, you would see that we have a high minus a low in this direction here. Okay, so what we're saying is we've got two functions, if you have them face the other direction, that need to be written in a little different format. So I will start with my parabola, my x equals y squared. That's this guy right here. That's x equals y squared. That is awful, so I'm going to do that one more time. Let me clean that up. So that's x equals y squared. And then for the red graph, this of course was y equals x minus 2. The problem is we would like to switch this up so that they both say x equals. So what I mean by that is over here you got a nice little x equals equation. Right here you've got a y equals equation. We want to switch that up. So what I'm going to do, I'm going to add 2 to both sides. And then we're going to get x equals y plus 2. All right, there you have it. Now I've got an x equals equation over here. All right, so that is going to allow us to subtract these two functions. And if I were to ask you which one is on the high side, I'm hoping you would say the line, because we're going to integrate from the line down to the curve. Now you got to turn the paper sideways to see this. Let me see if I can throw some special arrows in. We're going this direction, this direction. So this orange over here, this orange right here, this is our high function. And then the pink, that's our low. So we're going to go high minus low. And when we do so, we're going to have a dy situation instead. Now I want you thinking back to the old picture that we did on previous examples, and that thickness over there, let me highlight that right here, that thickness right there, that's a dy situation. It used to be a dx situation. I'll explain more next time I see you guys in class, but basic idea is we get to basically say area equals, and we're going to integrate from a certain y value, which is -1, up to positive 2, so this is the direction we're integrating. In fact, I'm going to go ahead and write y equals negative 1 to y equals 2 to remind us that that's what we're doing. And then my functions, let's see, the big one, the upper, the high function is the y plus 2. And then we're going to subtract the y squared. And there we go. We've got our integral set up. Notice I have a dy out back because I have variables that are y's, and my limits of integration are also y's. And at this point, I'm going to let you use the calculator to work that out, but this is definitely an easier integrand than the last time. I mean, if you wanted to, you could drop the y equals out there. You can also just drop these extra brackets and just write this simply, like so. At this point, though, we want you to pretend like those are x's for your calculator's sake, and put that in the calculator. You should get a 4.5. Let me clean that up a little bit because that doesn't look like a 5, but it should be a 4.5 is your final answer. So take a moment, make sure you can get that to happen in your calculator, and I think you would agree that that is a much faster way compared to what we did previously when we ran through that example by splitting it into multiple integrals. Kind of nice when you do not have to split it into multiple integrals. All right, there we go. We are done.